Welcome to IDS KT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today, we are diving into one of the most exciting shifts in military aviation: how iron-based stealth coatings are making radar invisibility accessible to more than just the world's superpowers. For decades, stealth has been the domain of elite aircraft and billion-dollar defense programs. Think of the iconic F-117 Nighthawk or the cutting-edge F-35. These jets are invisible to radar, hard to track with heat sensors, and engineered to survive in the most contested airspaces on Earth. But this kind of technology came at an enormous cost, both financially and logistically. Until now, stealth has become a necessity, not a luxury. With modern integrated air defense systems using radar, infrared, and optical tracking to monitor every inch of sky, being seen means being vulnerable. That's why stealth coatings designed to absorb radar and suppress heat are a critical defense layer for any advanced aircraft. Traditionally, these coatings were made using exotic and expensive materials like gold, platinum, or carbon nanotubes. Applying them required multi-million-dollar vacuum chambers, and even a single mission could demand hours of delicate maintenance. The result? Only the biggest players, countries with massive defense budgets, could afford to build and maintain truly stealthy fleets. But in 2024, that equation changed. A team of researchers from China's Naval Equipment Department introduced a game-changing solution: stealth coatings made primarily from nanoscale layers of iron. Not only do these coatings cost less than $1 per kilogram, but they can be fabricated using commercially available laser processors costing as little as $7,000. That's compared to the millions spent on legacy systems. The iron-based material performs even better in some aspects, offering infrared suppression above 80% and withstanding temperatures up to 230 degrees Celsius. In short, it's cheaper, simpler, and more robust. This breakthrough is democratizing stealth in a way we've never seen before. Suddenly, countries that previously couldn't afford high-end stealth technology are finding new opportunities. Aging fighter jets like the F-16 or the Su-27 can now be retrofitted with iron-based coatings to extend their operational value and survivability. Drones like China's GJ-11 benefit enormously from these coatings, allowing them to fly closer to enemy defenses while avoiding radar and heat-seeking missiles. Even naval forces are exploring these materials to reduce ship signatures on radar at sea. Of course, these coatings aren't magic. At extreme conditions like hypersonic speeds where surface temperatures can climb above 1000 degrees Celsius, iron nanocoatings still face durability challenges. And as detection technologies evolve, with quantum radar and multispectral lidar on the rise, even the best stealth strategies will need to evolve too. That's where smart materials and AI are stepping in. Some coatings now integrate self-healing polymers that automatically seal scratches or damage sustained during flight, extending stealth integrity without constant maintenance. Others are designed using AI algorithms trained to optimize how the material scatters or absorbs electromagnetic waves based on the angle, frequency, or incoming radar type. Stealth is becoming adaptive, living, and intelligent. And the future only gets more futuristic. Research is moving toward multifunctional stealth coating skins that can not only evade radar but also monitor their own health, detect surface stress, and even generate power from radar energy. Some designs mimic structures found in nature, like the nanostructures on moth eyes that absorb light without reflecting it. These biomimetic surfaces promise better radar and visual cloaking across multiple spectrums. We're even beginning to see stealth technologies that integrate quantum sensing coatings that allow drones or aircraft to remain invisible while passively collecting intelligence across the electromagnetic spectrum. Imagine an aircraft that not only goes unseen but silently gathers strategic data while flying through contested territory. That's not science fiction anymore, it's in development. All of this points to one thing: the stealth revolution has begun. What was once the privilege of billion-dollar programs is now available for a fraction of the cost. From iron-based coatings to AI-optimized stealth surfaces, the next generation of radar-evading technology is cheaper, smarter, and more adaptable than ever. This isn't just about making aircraft harder to detect, it's about changing the entire equation of air power and putting advanced survivability into the hands of many. The future of stealth isn't coated in gold. It's built from iron, driven by data, and designed by algorithms. And it's already changing the skies.